This is the only quadratic sequences question you need to see. I'm going to cover all bases here. I'm also going to do a cheeky proof of how you can find the nth term of quadratic sequences super quickly. But first I'll show you how to find it super quickly and then proof afterwards, just so you guys believe me. First question says the nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term is -2 and the fourth term is 12. Find the sixth term. Okay, so this is a quadratic sequence, but they've given you the form and they've given you the terms here. So the second term is -2. The second term means when n is 2. Pardon me, mate. So when n is 2, you get -2. So we have a 2 squared plus b times 2. Yes, they're saying when you substitute n is 2, you get -2. So that's 4a plus 2b is -2. We can divide through by 2 to get 2a plus b is -1. They should already be giving you vibes of a particular topic. Do you notice? Here, the fourth term, when n is 4, this subs that in. When you sub in 4, you get 4 squared, 4 squared, yeah, which is 16a. I'll just write it. So when you sub in n is 4, you get 12. 4 squared, 16a plus 4b is 12. Here we can divide through by 4. So we'd get 4a plus b is 13. We need to solve these two simultaneous equations. So let's write under. Did you get that? Here, the b's are the same, so we're going to use elimination and subtract. 4a minus 2a is 2a, b minus b. 3 minus -1 is quattro. A is 2. Take a is 2, sub into one of them. Probably this one. Actually, it doesn't matter. Subbing into that one. 2a is 4, plus b is -1. And then we subtract 4. So we get b is -5. So we have, what was it? It was an squared plus bn. So we have 2n squared minus 5n is that sequence. Now, they have given us the terms in the sequence, and they have asked us to find the nth term of that quadratic. And it's only 2 marks. It's not a lot. Sometimes they give you 3 marks for these questions. So we have 0, 2, 6, 12, 20. So quadratic sequences are such that the second difference is the same. Linear sequences, the first differences are the same. So let's take a look. So here I'm adding 2, adding 4, adding 6, adding 8. Here I'm adding 2, adding 2, adding 2. Now the general quadratic looks like this. an squared bn plus c. Here they had an squared plus bn. They already knew that c was going to be 0. All you guys need to remember is that the second difference is 2a. The first difference is 3a plus b. And this is a plus b plus c. So we just solve. If 2a is 2, then a is 1. 2 times a number is 2. That number is 1. Here, 3a plus b is 2. 3a. If a is 1, 3a is 3. 3 plus b is 2. What is b then? Well, b, when you subtract 3, is -1. And then finally, let me just rub this out now. Finally, what is it? Here, a plus b plus c is 0. Well, if a is 1, b is -1, we have 1 minus 1 plus c is 0. Well, that's just 0, so c is 0. So there you go, you get an squared, 1n squared, minus 1n plus 0, which is just n squared minus n. That's your quadratic sequence. So students always ask me, especially on TikTok, why is this true? Let me prove it to you. That rhymes. It's actually very simple proof. You don't need to know why, but I think for belief purposes, it's good for you guys to see it. Let me change pen. Hopefully this pen works nicer. So like I showed you guys before, the general quadratic looks like this. So let's look at n equals 1, n equals 2, n equals 3. You only need to look at a couple of terms. Okay, so we're looking at the first term, second term, third term of this general sequence. If I substitute 1 here, I get 1 squared, which is 1a. 1a, which is just a, plus. When you sub 1 into here, you get b. And then plus c is just plus c. Let me add a boundary there. When you sub in 2, here, 2 squared is 4a. Plus, when you sub in 2 here, you get 2b. And then you get that c. Subbing in 3, 3 squared. So 3 squared is 9a plus, subbing in 3, 3b plus c. Right, let's work out the first differences. So, the first differences are, what do you need to add to a to get 4a? You need to add 3a. What do you need to add to b to get 2b? b plus b is 2b. The c's are all constant. What do you need to add to this to get this? What do you need to add to 4a to get 9a? It's 5a. What do you need to add to 2b to get 3b? It's just b. Now look at this. What do you have to add to this to get this? 3a plus what is 5a? It's 2a. And there we go. That's where we get it from. Here is my common difference. And if you guys carried on, it would say 2a, 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 2a. Here you can see that first difference being 3a plus b, which I told you guys before. And that first term being a plus b plus c. And that's your proof. So, guys, just trust me on it. Use it. It's going to make your lives a lot simpler. But if you haven't seen that proof before, I'd appreciate if you hit the like button, if you subscribe, if you learn something in general, like anyway, subscribe for more maths content. And if you're interested in my GCSE maths courses, more details in the description. And feel free to join the Lund Gang Reddit to submit your own questions and get feedback from my community. I'll see you guys in the next video. Nice one, dive.